Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week with me, Greer Jackson. This time we've been getting up to speed with Paul's query.
I recall once watching a programme about elevators, which inferred that there was almost no restriction in the speed that an elevator could ascend for the human body, but there was a limiting speed for the descent. Is this true?
Well, Paul, lucky for you, I know an engineer at Cambridge University who knows a thing or two about lifts. Meet Dr. Philip Garsed.
A typical express lift can travel at speeds of up to 22 miles an hour, although this year we'll see the first high-speed lifts capable of travelling at over 40 miles an hour.
Now, what confuses me is that trains can travel at up to 360 miles per hour. Lifts go at a measly 22 miles an hour on average. I wanted to know why elevator engineers haven't quite cracked this nut. So come on, Philip, explain yourself.
The main difference with a lift is that it goes up and down. Because the Earth's atmosphere gets thinner as you go higher, a person in a lift experiences a change in air pressure as they travel. On a fast lift, this change is rapid enough to cause noticeable pressure differences in the body. One of the most sensitive parts of the body to changes in pressure is the ear. This is because the inner ear is quite well sealed, and air has to travel along a thin tube known as the eustachian tube to leave or enter. As a result, it can take a while for a change in pressure to equalise across the eardrum. And a pressure difference across the eardrum causes it to bulge, and that's uncomfortable at best and can even be a painful experience. It just so happens that this pressure equalisation works better if you're ascending rather than descending. And this is because the walls of this eustachian tube are a little bit floppy, a bit like the neck of a balloon. Air comes out easily when it's inflated, but it's a lot more difficult to get air in. And if you've been in a plane, you'll probably have noticed that landing is much more painful on the ears than takeoff, even though the aircraft descends much faster than it descends.
And it's the same with lifts. They can go fast on the way up, but have to go slower on the way down.
Going up.
The maximum speed of ascent and descent is set by how much pain the passengers can reasonably bear. Lift manufacturers can get around the problem a bit by pressurising the lift. But even so, the new and fancy 40 mile an hour lifts can only go up the building at that speed. They come down at a much more sedate 22 miles an hour.
Okay, but when I think about getting into a lift, I automatically remember that sinking feeling in my stomach, like I left it somewhere on the ground floor. I don't tend to think of my ears being a problem. However, Philip told me that, like your ears, that sinking sensation is all to do with the rate of acceleration. And if you overdo it, well, that's not too pleasant either.
A person in a lift will start to either feel really crushingly heavy or nearly weightless. To avoid these problems, lift manufacturers usually limit the acceleration to about 0.1 g. So if you're in a lift, you have the sensation that your weight changes by only about 10%. So yes, you're right. A lift does have different limits on its speed depending on whether it's going up or down, but it's our biology that prevents us going faster, not our engineering.
Doors opening.
Cambridge's Dr. Philip Garsed to the rescue. Thank you very much. No doubt next time we'll be getting all spaced out with Jeff's question.
If we received an encrypted message from space, would we be able to recognise it? And if so, understand it?
Great question, Jeff. Tune in next time to find out. But if you think you know, please do get in touch. Tweet at Naked Scientists, find us on Facebook, and give us a like, of course, or you can join in the debate on the forum. It's nakedscientists.com/forum. Until next time, I've been Greer Jackson, and this is Question of the Week.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.